بسم الله الرحمن الرحيم. كنت في المحاضرة السابقة قد راجعت how to use Newton-Raphson to solve nonlinear algebraic equations. اليوم إن شاء الله نأخذ اللي هو Newton-Raphson load flow، ورايح أبلش بالmathematical formulation نتعلم how to write equations for a power system using Newton-Raphson. والمحاضرات القادمة إن شاء الله نأخذ examples. إن Newton-Raphson load flow فكرتها we use known PI and QI to find unknown angles and voltage magnitudes at bus I. PI remember هي net injected real power at bus I، و QI is net injected reactive power at bus I. وأذكركم إنه PI تكون known at all buses طبعا except الريفرنس bus. عادة بالمعادلات احنا ما نكتب معادلة للريفرنس bus، فلما أحكي عن البصز باستثناء الريفرنس bus. و QI تكون known at all load buses except الريفرنس bus. إذن الفرق PI تكون معروفة عند كل البصز طبعا باستثناء الريفرنس bus، بينما QI تكون معروفة at load buses. نتذكر أيضا إنه we don't write equations for the reference bus. نتذكر angle delta I is unknown at all buses except the reference bus، لأنه عند الريفرنس bus تكون angle تساوي 0. و voltage magnitude is unknown غير معروفة at load buses، لأنها تكون عند الجنريتر buses معروفة قيمتها مثبتة. Also net injected real power PI is known at all buses باستثناء الريفرنس bus. 5 net injected reactive power is known at load buses. فكرة Newton-Raphson for each unknown delta I تكون PI at this bus is known. For each unknown voltage magnitude تكون reactive power is known. So الفكرة we use known PIs و QIs to find the angles وال voltage magnitudes. هاي الفكرتها. Example: if bus 1 is the reference bus وكان عندي الباور سيستم for bus system، وين الانجل تكون مجهولة؟ at all buses طبعا except the reference bus. احنا ما بنحكي عن variables of the reference bus. وين الفولتية تكون مجهولة؟ مثلا عن bus number 2 number 4، which means إنه تكون bus number 2 و bus number 4 are load buses. إذن الفكرة we have 5 unknowns 1 2 3 4 5. These are the unknowns we want to find. I have 5 unknowns, then I need 5 knowns اللي هما B2 P3 P4 Q2 و Q4. إذا نشوف مقابل دلتا 2 P2 مقابل دلتا 3 P3 مقابل الدلتا 4 P4 مقابل V2 magnitude Q2 and so on. بعد شوي لما أكتب equations of B2 P3 P4 و Q2 و Q4 اللي هم known values أو quantities أو expressions, they will form 5 nonlinear algebraic equations which be to be solved by Newton-Raphson iterative method. إذن continuation لنيوتن-رافسون load flow. Recall that the net injected real power and net injected reactive power Pi and Qi are given by the following two equations we derived in the class 2 weeks ago. Pi equals the summation from j to psi 1 up to number of buses and this expression, if you remember. The only difference between Pi and Qi is to replace cosine by sine. We will call from now and on this expression, the summation, we will call it Pi calculated. Pi calculated. Also, Qi, which is this summation, I will call it Qi calculated. We will see later why. I know that also the net injected real power at bus I should equals BGI minus B demand I. This is fixed number and this is fixed number. So this difference is a fixed number. I will call it Pi scheduled. So to distinguish this expression from this expression, I will call this Pi calculated and this is Pi scheduled or specified. To distinguish this expression, the summation expression, and this constant expression, I will call this as Qi calculated, while I will call this Qi scheduled. Qgi is constant, or Qdi is constant, so the difference is constant. Finally, at each bus, Pi calculated should equal to Pi scheduled, and Qi calculated is equal to Qi scheduled. These will form nonlinear algebraic equations. Then Pi calculated, it means calculated value. How to get this? From the summation expression. It's a nonlinear expression. Qi calculated means the calculated value. How to get this value? From the summation expression. Pi scheduled, as I mentioned, means a scheduled value, which is constant. Qi scheduled is scheduled value, which is also constant. At each bus, Pi calculated should be equal to Qi scheduled. Pi, this is nonlinear algebraic expression. This is constant. So at each bus I, this form a nonlinear algebraic equation. Also, Qi calculated equals Qi scheduled. At each bus, this form nonlinear algebraic equation. So these are nonlinear algebraic equations to be solved by iterative solution. Let's take as an example to be familiar with Newton-Raphson formulation in a power system. Let's assume we have 3-bus system, bus 1, 2, and bus 3. Let's assume reference bus is bus number 1. Voltage magnitude at this bus is 1.05 and angle is تساوي 0 لأنه reference bus. So we don't need to write equations for this reference bus. We look at the rest of buses, 2 buses. Okay, when it comes to bus number 2, This is a generator bus. So B generated at 2 is given as 3 per unit. V2 magnitude is given as 1 per unit. Let's assume S demand at bus number 2 is 4 plus J2. Bus number 3 is a load bus. S demand at bus 3 is 5 plus J3. Well, let's assume the impedances of the three transmission lines are equal. Z12 تساوي J.1, Z23 J.1, Z13 J.1. المطلوب use the given information to write the necessary set of nonlinear algebraic equations to solve the load flow using Newton-Raphson for this system. The first step, usually in any load flow methodology, is to find the admittance matrix, Y or Y bus. So for this system, admittance matrix تساوي 3 by 3 matrix minus J20, J10, J10, J10 minus J20, and so on. Then you have in a Newton-Raphson to convert this to polar form, either in degree or in radians. For example, this is Y11 magnitude. This is the angle theta 11. This is Y12. And this is the angle theta 12, and so on. So let's initially exclude reference bus, which is bus number 1. For this system, let's see what are the knowns and what are the unknowns. Let's see. At bus number 2, we have 4 quantities. For this bus, we have 4 quantities: delta 2, V2, P2, and Q2. Let's see which of these is known and which is unknown. For example, delta 2 is unknown, V2 is known, B2 is known. B2, for example, 3 minus 4, so minus 1, this is known, but this is unknown. At bus number 3, we have four quantities: delta 3, V3 magnitude, and B3, and Q3. Delta 3 is unknown, V3 is unknown, P3 is known, this is known. So, for all buses except the reference, the unknowns are delta 2, delta 3, or V3. Angles at all buses except the reference, and voltage at all load buses. If you look at the known values, these are P2, P3, Q3. يعني أمام كل unknown angle there is known real power injection. وأمام كل voltage Q is known. So these 3 unknowns need 3 nonlinear algebraic equations. The key for solution that P2 calculated تساوي P2 scheduled, و P3 calculated تساوي P3 scheduled, و Q3 calculated is Q3 scheduled. إذا أنقل واحدة من طرف لآخر, we call this mismatches, differences I mean, delta P2, delta B3, delta Q3. So delta B2 إذا ودينا هاي للجهة اليمين, P2 scheduled minus P2 calculated, delta B3, P3 scheduled minus P3 calculated, and so on. When we reach a solution after many iterations, delta B should become 0. All of these should, if there is a convergence, each of them should finally reach 0 or epsilon. So let's see what are the necessary equations. First equation, P2 calculated equals to P2 scheduled. This is the first equation. What is P2 calculated? It's from the expression. This expression at bus number 2. Okay, we have 3 terms as we mentioned in the class. P2, forget about calculated. P2, V2, V1, Y21 magnitude cosine plus V2 squared, Y22 cosine delta 2 minus delta 2. The third term bus 2 with respect to bus 3, V2, V3, Y, and so on. Now in this equation, V2 is known. V1 magnitude is known. Well, admittances are known. Finally, only unknowns should appear in the equation. فنعوض مكان كل إشي معروف من هذول الانجلز والادمتانسز والفولتج ماجنتيودز اللي عندهم تشيك. هذول معروفات. فقط يظهر بهذه المعادلة finally 3 unknowns delta 2 delta 3 and V3 magnitude. But B2 scheduled for this bus, this is B2 calculated, that comes from the mathematical expression, the summation. P2 scheduled is BG2 minus B demand 2, which is 3 minus 4, which is minus 1. So B2 calculated should equals B2 scheduled for balance at each bus. This is called real power balance at each bus. Delta P2, P2 scheduled minus P2 calculated. P2 scheduled is a constant minus 1. P2 calculated is this expression بعد تعويض القيم طبعا اللي معروفة وثابتة فيه. نروح على المعادلة الثانية اللي هو معادلة P3 to find delta 3. حكينا P3 calculated should finally تساوي P3 scheduled or delta P3. إذا ودينا هاي للطرف الثاني معادلة P3 scheduled minus P3 calculated. Then this is P3 calculated. Let's write equation for this second equation. Then let's write nonlinear algebraic equation for this second equation. P2 calculated of at bus number 3 is 3 terms زي ما أخذنا بالصف وأخذنا أمثلة عليهم. 3 terms بس 3 مع بس 1 بس 3 مع بس 2 بس 3 مع نفسها. وبعد ما أكتب هذا الإكسبريشن أعوض القيم الثابتة اللي معروفة معي. مثلا دلتا 1 0 واي 3 1 10 في 1 معروفة 1.05 في 3 مجهولة and so on. يتبقى finally بهذه المعادلة الأشياء اللي unknowns اللي هم دلتا 2 دلتا 3 and V3 magnitude. إذن this is the second equation. So P3 scheduled for this system, B generated is 0, there is no generator here, minus B demand 5, which is minus 5. So delta B3, the mismatch at bus number 3 is B3 scheduled ناقص B3 calculated. No, this should be scheduled. Sorry for that. This is scheduled and this is calculated. Let's see at bus number 3. Also, the third equation is to write Q3 to find V3, which means Q3 calculated should be equal to Q3 scheduled. إذا أوديها الجهة الثانية دلتا Q3 تساوي Q3 scheduled minus 3 Q3 calculated. Also, Q3 has 3 terms, the same as the previous equation, but with one exception. Instead of cosine we put sine here. Again, الأشياء اللي عندها check صح هاي معروفة fixed values أعوض قيمها. Q3 scheduled, it is Q generated and 3, no generator, so QG3 is 0, minus Q3 Q demand at 3, 0 minus 3, which is minus 3. Delta Q3 is Q3 scheduled minus Q3 calculated. So initially we put here the constant, then the mathematical expression that comes from the summation. Okay, so this is the third equation. Note that equations 1, 2, and 3 are nonlinear algebraic equations which should be solved by Newton-Raphson. In the 3 equations, all terms are known values or quantities are known values, have known values, except the unknown variables delta 2, delta 3, and V3. Then we will construct the Newton-Raphson iterative equation as follows. Here we put the 3 unknowns, angles first, then voltage magnitudes. This is for iteration k plus 1. K plus 1 is for each variable. These are the same variables here for iteration k. Plus, this is, we call it the Jacobian matrix, as we mentioned بمحاضرة مراجعة نيوتن-رافسون. For iteration k, the inverse of this matrix, this is 3 by 3, because we have 3 unknowns, 3 by 3. Note that هذا الرو السطر الأولاني محجوز ل P2, السطر الثاني ل P3, السطر الثالث ل Q3. لاحظوا إنه مقابل كل أنجل في عندي ريال باور، مقابل كل فولتج unknown في رياكتيف باور. العمود الأول هذا محجوز، العمود الأول لدلتا 2 لفيرست فاريبل، العمود الثاني لدلتا 3، والعمود الثالث لV3 ماجنتيود. وهنا بالجاكوبيان نحط البارشال ديريفاتيفز ل P2 with respect to delta 2 مثلا بالسطر الأولاني، all partial derivatives of P2 with respect to delta 2 with respect to delta 3 with respect to V3 magnitude. السطر الثاني partial P3 partial delta 2 partial P3 partial delta 3 partial B3 with respect to V3 magnitude. هون محجوز كله ل Q3 partial derivatives of Q3 with respect to delta 2 with respect to delta 3 with respect to V3. Here we put the mismatches delta B2 of K, delta B3 of K. This is for each term. Also this K is for each term. This is for each term of them. But للسمبليفيكيشن احنا عادة نحط الكاونتر برا، بس مفهوم ضمنا انه لكل ترم بالمعادلات. اوكي. سو هاي المعادلة اللي استخدمها كل iteration. هلا شو المشكلة عندي؟ المشكلة how to find هذول البارشل derivatives. هو مو مشكلة، once كتبنا expression ل P2 نقدر نلقى لها البارشل derivatives، وذيس already احنا بينا كيف نحسبهم، بس لازم نحسبهم كل iteration. اذا هذول الكوانتيتيز اللي جوات الجاكوبيان ماتريكس، وهذول اللي بالمس ماتشز لازم re-evaluated every iteration. For example خلينا نوريكم بس حالة واحدة how to find مثلا delta B2 by delta delta 2. I know that B2 أعني فيها هاي البي 2 اللي بدي اشتقها هي نفس اللي اجيبها من السميشن which is P2 calculated. P2 calculated اللي قبل شوي بعد ما أعوض فيها الأشياء اللي معروفة fixed تقول لهاي المعادلة 1 ضرب 1.05 and so on. حكينا زي ما حكينا سابقا مفروض يظهر بهاي المعادلة بشكل النهائي only unknowns دلتا 2 ودلتا 3 وV3 magnitude. هلا بعد ما أعوض القيم المعروفة معي ويتبقى بالمعادلة فقط الأنونز أقدر أحسب البارشل ديريفاتيف of B2. For example partial B2 partial delta 2 it is لا تنسوا إنه derivative of cosine is minus sign. So this is the derivative of partial B2 partial delta 2 minus 10.5 sine delta 2 again minus 10 and so on. وإذا بدي إياها هاي الفاليو every iteration أحط الكاونتر فوق الفاريبلز اللي unknowns يتغيروا معي. هذولا should be updated الفاليوز in every iteration أعوض بمكانهم. كيف ممكن ألقى partial دلتا بي 2 عفوا دلتا بي 2 اوف كي؟ حكينا إنه قبل شوي دلتا بي 2 هي بي 2 scheduled ناقص بي 2 calculated. B2 scheduled at this bus حسبناها قبل شوي minus 1 minus B2 calculated اللي هي نفس هذا الإكسبريشن. فإذا بدي إياها of iteration K أحسبها B2 scheduled minus B2 calculated يظهر فقط الكاونتر هنا بهذا الشكل. إذا مطلوب مني أحسب partial P2 with respect to delta 3 this is P2. كيف أشتق with respect to delta 3 for example this is 0 لأنه ما في delta 3. هاي عبارة عن minus 10 V3 magnitude sin delta 2 minus delta 3 ناقص 90 again في minus 1 لأنه بدي أشتق هاي with respect to delta 3. لو بدي أحسب for example partial B2 partial V3 this is B2 with respect to V3 magnitude this is 0 لأنه ما فيها V3 تبدو وكأنها fixed constant. وشو مشتقة هاي with respect to V3 it is 10 cosine delta 2 and so on. الله يعطيكم العافية، وأتمنى أنكم تتفرجوا على المحاضرة اللي راجعت فيها هي كم صفحة 3-4 صفحات مع examples how to solve nonlinear algebraic equations using Newton-Raphson load flow. يعطيكم العافية.